What is happening, IED engineers? This is Mr. Suffern here. And today, what I would like to go over on this virtual Friday is to cover activity 1.2.4. I know there are some students who are trying to fully understand the concept of dimensioning. And I want to just cover what we've done in class and then go over the assignment for today. So let us begin with the end in mind, okay? So let me share my screen. And give me one moment while I do that. Okay, here you'll see our Canvas page, Activity 124, Fundamentals of Dimensioning. We have covered everything in this activity, but I want to just start with with our assignment for today. And our assignment for today is step 7. So let me just scroll all the way up. I'm gonna scroll all the way up. And what I am going to do is open up PLTW activity 1.2.4. So now I'm in the Project Lead the Way activity. So when I scroll all the way down, we've reviewed step 2 on the dimensioning lines. We've covered the how to follow the dimensioning flowchart and how to approach dimensioning an object. We've covered number 4 in class and how to dimension. And we're going to just touch on all of this today. And our assignment is going to be going to our dimensioning cards. And I gave that to everyone. And very briefly, I will show you what that is. But let us rewind. And what I would like to do is go to our dimensioning worksheet. Okay, I'm going to stop share. And what I'm going to do is share my camera. Okay, so, okay. Relative to our dimensioning flowchart, okay, real briefly, it is very, very important that you go over and study the dimensioning guidelines. You will see this on your exam, you will see this on your midterm, you will see this on your final exam. So make sure you go over the guidelines, understand them, and how to apply these guidelines to your dimensioning, okay? And when you are dimensioning, firstly, you're going to create a multi-view drawing, and I am going to reference our dimensioning worksheet. And our dimensioning worksheet, we're going to look at drawing 1. And we've done this in class, but I'm going to do it again. Okay, so we have our multi-view drawing, and we need to count the number of features. Okay, now, what is a feature? A feature in a technical drawing it just refers to a distinct part or a characteristic of a design or an object that requires specific dimensions, that defines the size, shape, and or the location. Okay, so features and dimensioning can include things like edges, surfaces, holes, slots, curves, and other geometric shapes that are a part of a component. Okay, so according to the dimensioning flowchart, it is imperative that we count the number of features. Okay, so according to drawing 1, let us count the number of features of drawing 1. So this object right here, we've covered that our first feature is our small hole. Our next feature is our large hole. And our third feature is the entire block itself, okay? So in this case, we have 3 features. So what we did in class, we jotted down a table in our engineering notebook, okay? And according to our dimensioning flow chart, we've counted the number of features, and now we're going to select the best view to represent each feature, okay? And then we're going to dimension each feature according to size and location. So it's very handy to keep this dimensioning flow chart. So as we know, we have our first feature is our small hole, okay? So let's do this. Give me 1 second here. I am going to, okay. So on our table, we're going to reference our small hole as our first feature. So let's go ahead and just jot that down. Our small hole. Okay, so that's our first feature. And relative to the location of our first feature, what is the best view to represent our feature? Would the best view of our first feature, would that be the top view, or would it be the front view? If you said the top view, you are correct. So the best view to dimension our feature is our top view. So I'm going to, on our table, I'm going to put top. And this pretty much helps you to understand the concept of how we're going to use the dimensioning flow chart to dimension our object, okay? So we have our first feature, which is our small hole. The best view to dimension our feature is the top view of our orthographic projection of our multi-view sketch. And then we're going to annotate the size and annotate the location of our feature. So let's talk about our second feature. So our second feature is our hole, our large hole. So I know our second feature is our large hole. I'm going to jot that down on my table. Okay. And my question to you, in reference to our second feature, our large hole, what is the best view to represent or to dimension our large hole? If you said our front view of our multi-view sketch, you are correct. So I'm going to put our best view is going to be our front. Okay. And we'll get to sizing and annotating the location in a moment. So now our third feature is the large block itself. And that will be the front view. So I'm going to put on our feature, on our table, the block. Okay. And the best view, what would be the best view to dimension our whole entire block? Well, we're going to use both the top and the front view because we have dimensions. So we have to dimension our width, depth, the height, and our depth dimension is going to be on our top view. So both views we're going to use to dimension our large or our entire block. So I'm going to put the front and the top view. Okay. Let's go back to our dimensioning flow chart. Now that we've counted the features and we select the best view to represent each feature, so let us dimension our small hole first. So we know that our top view to dimension our small hole is the best view to dimension that particular feature. Now we're going to dimension our small hole according to the size and location. All right, so let's go back. Now, what I explained that when you are dimensioning a feature, you're going to dimension the three primary views. And we know our primary view that goes side to side, we know that is our width, okay? And our width is going to be on our front view. We know that our depth is going to be our front to back, and that's our direction for depth. And we know our top to bottom is height. So we're going to have to dimension all three primary lines. Okay. So with regard to our feature, which is our top hole, okay, we know according to this scale, let me zoom in. This scale says 2 boxes equal to 1 inch. Okay. So if I go to my hole, I know that this hole fits into 1 box. So this hole will have a dimension of a half inch in diameter. So I am going to put my diameter sign, and we're going to say 0.5. And we're going to use a leader line to specify our dimension. So this hole, the size of this hole is a diameter of 0.5. Okay. Okay. So what I'm going to do, I'm going to go to our table, and I am going to put diameter of 0.5 inch. Now that we have the size, now where is the location of the hole? Now, relative to the hole is going to be dimensioned in 2 directions, okay? So relative to the bottom left-hand corner of our shape, we know that it's going to be a certain distance away from this bottom corner to the center of our hole, going to our right. And we know that from the bottom corner to the center of the hole, from the front, okay? So what I'm going to do is annotate my extension lines. And we know our extension line is not going to be touching the actual object. So that's one location. And here's my extension line. And here's my extension line. Now we're going to specify the location of our hole. So I know that since 2 boxes, let me get this in the camera, since 2 boxes equals 1 inch, I know from the front edge, we know that this is a half an inch. So I'm going to put 0.5. Matter of fact, here's what I'm going to do. Since I don't have a lot of room to put my dimension line, I am going to annotate my dimension line as so. And I'm going to put 0.5 right here with a little arrow. Okay. So that is a half an inch from the front edge. So what about this dimension? So I know that this is a box right here and a half. So we're going to call that 3/4 or 0.75. Okay. Just like this. And I'm going to put 0.75 I'm going to draw an arrow. So our feature, in reference to this feature, we have our size and location of our hole. So we have the size of our hole, which is a diameter of a half an inch, and we have our location, which is a half an inch from the front edge and 3/4 inch or 0.75 inches away from the left edge. So what I'm going to do is I am going to annotate the location. So we know that our location is in 2 directions. I'll just abbreviate that. And we know that it is a half an inch from the front edge. Okay, so we know it's a half inch from the front edge, and we know it's 0.75 inches from the left edge. Okay. Okay. So what I'm going to do right now, we've already dimensioned one hole. You should be able to dimension this hole. So you're going to dimension the size of the hole and the location of the hole. Okay. This is your exemplar right here. This is your exemplar right here. So let's go ahead and dimension the whole entire block. So again, we're going to dimension in 3 directions. Okay. Width, depth, and height. So if I'm going to dimension our whole entire block, we know that our width from here to this point, that's our width. So our width is going to, so this line right here is going to be this line right here. So I'm going to dimension it from the top. Okay. I'm going to dimension it from the top. So I know from this edge right here to this edge right here, we know that this is 1 inch, 2 inch, 3 inches. It's 3.5 inches. So I'm going to put 3.5 and I'm going to annotate my dimension lines. Okay. So now we've already dimensioned our width. Let's go ahead and dimension our height. So we're going to dimension from the bottom to the top. And that is this area right here. So let's go ahead and put our extension lines. And let's go ahead and dimension. So according to our scale, 2 boxes equal 1 inch, 1 inch, 2 inch, and half. So that's 2.5 inches. 2.5 inches. And let me draw my dimension lines. Okay. So now we've dimensioned our width our depth, I'm sorry, our height. Now it's time to dimension our depth. Now, how do I know where our depth is? Technically, our right side view, this is our right side view right here. Typically, our right side view is our depth, right? So if I took this isometric block right here and I oriented this block where you can just only see the top view, you know that this edge right here is represents our depth. Okay, so we know that this edge right here is not height, but it is depth. So we're going to dimension our depth. Just like so. And we know 2 boxes equals 1 inch. And I'm going to put my dimension lines. Okay, just like so. And let's go ahead and annotate our table. Now, again, I didn't require you to annotate your table. It is a good practice for you to do to get practice understanding this concept of dimensioning. Okay, so we're dimensioning our features. So which feature that we just dimensioned? We just dimensioned our entire block. Why is our block, the front and top view, the best view? Well, because we needed to dimension our width and our height was dimensioned on our front view. Our depth was dimensioned on our top view. That's why both the front and the top view are the best views to dimension this feature. Okay. Now, what is the size? All right, so our size is going to be in 3 directions. So our size is width, and our width is 3.5 inches. 3.5. And what is our height? Our height is 2.5 inches. I'm going to write 2.5. And what about our depth? And we know our depth. Let me see. Yeah, our depth is 1 inch. Whoops. Okay. And our location of our large block, I would say this feature, defines the extent of the object. Okay. So this is pretty much the process of dimensioning. So when you're reading your flow chart, when you dimension one of your features according to size and location, once you dimension one of your features, you go down and ask yourself a question. Is every feature dimensioned according to size and location? If you did not dimension feature 2 and feature 3, you just go back up here and repeat this process until all features are properly dimensioned. Once your feature is properly dimensioned, you just move on, dimension the overall object, all right? And then you're going to ask yourself another question. Does every view a view on your multi-view sketch has greater than or equal to one dimension? If not, then you can delete one of your dimensions, and notice that drawing 1 only has our front view and top view. It does not have the right side view. All right, because we didn't need it. It didn't have any dimensions, okay? All right, so that's a quick rundown of how you are going to dimension. How do you properly dimension, okay? So once you have all of these dimensions, then you're just going to finish up the rest of the assignment, and that's in your submission details. Let's take it to, now this is your assignment for today. Your assignment for today is take your dimensioning cards and do as follows. And it says, identify dimensioning errors and omissions in the drawing and justify your interpretation. Indicate which drawing from each pair is a better example of a properly dimensioned drawing. So let's do drawing 1 first, and you're going to do drawing 2 and drawing 3 and drawing 4, okay? So what you're going to do in your engineering notebook, you're going to have your dimensioning cards, okay? And what I'm going to do, I am going to look at drawing 1A and 1B, and I need to determine which one is incorrect. So visually analyze drawing 1A and drawing 1B. And what we are doing, we are referencing our guidelines. So which drawing breaks one of our 8 guidelines? Which drawing is incorrect? Is it drawing A or drawing B? As I visually analyze these 2 drawings, I know drawing 1A is incorrect. So what I'm going to do is I'm going to put a bullet, and I'm going to put drawing, trying to write so you can see I'm left-handed. Drawing 1A is incorrect. And I'm going to explain why it's incorrect. So what do you think? Why do you think this drawing is incorrect? Well, we know that our width size of our notch, which is one of our features, what do you think? There's no dimension for our notch, for our width. So I'm going to put right here, I'll put a little hollow bullet. I'm going to put the width our width size of the notch is what? I'm sorry, notch feature. It's not shown. Okay. So it's not shown right here. Is there any other errors in drawing 1A? Let's look at the height notch. So we know that according to our guidelines, you should not underdimension or overdimension. So our height of our notch feature is overdimensioned. So it has number 1 right here, referencing the height on our right side view. It also has it right here. That is over dimensioned. Over dimensioned. So we're going to annotate this, okay? Let's do it. So we're going to put another bullet, and we're going to put the height of the notch feature is what? Over dimension. Okay. I want to put comma the 1-inch dimension is duplicated. Okay. And relative to drawing 1A, there's 2 more errors. Okay. So the overall height is over dimensioned. So look at this height right here. So we have the overall height of our block is 2 inches. Well, they specified that here. 1 + 1 = 2. So that is over dimensioned as well. You're going to jot that down right here. There's one more bullet, one more error. The block depth is not shown. Where's the depth? Depth is right here. Is it shown? That look like depth. No, that's drawing B. Right here, the depth is not shown. Okay. Okay, so that's drawing 1A. We know drawing 1B is dimensioned correctly and is the better example of a properly dimensioned drawing. So you're going to annotate that right here. You're going to write drawing B is dimensioned correctly. Okay. And it's the better drawing, better example of a properly dimensioned drawing. So this is what you're doing for drawing 1, 2, 3, and 4. There is an assignment that is created so you can submit this, and the due date, the due time is Friday, today, at 12 o'clock noon. That is the due date. After that time, it is late. Okay? And there's going to be a separate assignment for that. Okay. Is there anything else I need to cover? Let's share that. All right, let's talk about this. So make sure you have a duty to read all of the literature and take a look at your submission details. It's all right here, submission details. Notice I have step 5 and I do not have step 7. Step 7, I have broken that out in a different assignment. You have step 8, step 13, conclusion questions, and going beyond. Okay? All right. So that is our time. I hope you have a wonderful day and a wonderful weekend, and I want you to stay dry. If you have any questions, you can go ahead and message me. Take care, guys. Peace.